Hello, and welcome to Algebra 2, Chapter 8.2, and today we're discussing exponential decay. So, exponential decay actually has the exact same original form as exponential growth. So notice I've pulled up the slide from the exponential growth video. So here was our form from exponential growth. So they're the same base form. The difference is going to be the value of b. So both of them have an a greater than 0, but the b for growth was greater than 1, and the b for decay is between 0 and 1. And I didn't really talk about it in the growth video, but b can never be 1 because 1 to any power is just 1. You just graph a horizontal line. So b does have to be a number other than 1. But that's the difference. So you can just look at the equation and tell if if b is greater than 1, it's going to be growth, and if b is between 0 and 1, it's going to be decay. So if we look at these examples here, it just says to state whether this is an exponential growth or an exponential decay function. And so the first one, 1/3 times 2 to the negative x power. Okay, now we haven't really addressed that negative x power, but if you remember your exponent rule, let's just do a over b to the negative power, that's going to switch things to the positive power. And so I could write this 1/3 times 1/2 to the positive x power. And so it's a lot easier to see from here that is going to be decay. Okay, so remember it's based off that b value. So if we look at the next one, our b value is 5/8, so that is decay. And our last one, our b value is 3/2. So 3/2 makes it be growth because that is greater than 1, even though it's still written as a fraction. So don't assume because it's a fraction, but because it's greater than 1. So the next thing we're going to do is we're going to graph them, and you graph them exactly like you graph exponential growth. So we're going to start with the table, and I would start with 0. 1/3 to the 0 power is 1, times -2 is -2, and so 0 we're going to be down at -2. And then I would put in 1, and 1/3 to the first power is 1/3, times -2 is -2/3. So at 1, we're at -2/3. And if we put in -1, 1/3 to the -1 power is actually a +3. And that times -2 is going to be -6. So these actually will come up this way and go along. There's still an asymptote there at 0, 0. Or not at 0, 0, at the x-axis. So these flip. Remember that your growth ones went like this, so these just are flipped. Alright, and they still have the same shifts. And so this is going to be a shift, and this is going to be a shift. And so to start out, you really just want to graph this. So, table, if I put in 0, I'm going to get 5, because 1/8 to the 0 power is 1, times 5 is 5. So we're going to get 0, 5. Okay. And then if I put in 1, that's going to be 5/8. So we're going to be at 1 and 5/8, so someplace in there. If I put in -1, I'm actually going to get 40, which is going to be way up high off the graph. And so, so I'll take those 2 points, knowing that my next one is, way, way up there. I'll take those 2 points and I'm going to shift them left 1, down 2. So they're going to go left 1, down 2. And when I draw this in, so it's not going to really touch the -2 because it's going to be so far up there. And it's going to come down along -2 because it moved down 2. So now, this is not the way the last one went, Okay, and that's because the last one had a negative a value. So this one is a positive a value. So this one goes like that, where our last one went like this, and that's the difference between if a is greater than 0 or if a is less than 0. All right, and our last one here, first of all, we want to state whether this is growth or decay. And so we're going to look at our b value, and it is decay because that is less than 1. Okay, and our a value is positive, so that tells us that this one is going to come down like this, right? And we're going to start with our parent function, which is here. So if I make a table here and put in 0, we're going to get 2. So at 0, we're at 2. And if I put in 1, we are at 8/5, which is 1 3/5. So we'll go over to 1 3/5. And if we put in -1, I believe we have 10/4, which would be like 5/2. I'll get there, 2.5. Okay. And so this one is not going to be as curved. And so you might actually, let's see if I can do this one here. If I put in -2, that is going to be 25/16 times 2. Oops, trying here without my calculator. So 25/8 would be, does it be 3 1/8? So -2, 3 1/8. And so, you know, they don't have to curve dramatically, but we do need to shift this one. This one is going to shift right 2 up 3. So each one of these needs to go right 2 up 3. Alright, and so our asymptote here is going to be at 3 because we moved that asymptote up to 3. So we're not going to be able to touch that line right there. So we're going to kind of come down like this and come along 3. And so not as curved as the other ones, but that is still an exponential decay. Alright, that's what I have for you for 8.2. Let me know if you have any questions. I'll see you in class.